Welcome back. I hope you try to solve this problem or at least thought about it. Uh, so to recap, we want to simulate which house Professor Goldluck is going to buy, and he wants a house that are big enough, and he wants a house. He will decide to buy a house if the house has a price per square foot that's no more than half of the highest one he has seen. So we've looked at this before. So to start, we should think about what are the data we have to maintain while going through the houses. So obviously we need to maintain information, the highest price per square foot we have seen so far, and that one has to be updated each time we see a new house. And also, because each house will stay on the market for 2 days, we also need to store the information of the house from previous day. So at any time other than day one, we will be having information from 2 houses. And also, one thing that can simplify the code is we actually don't need to store the information of the house the Professor Goldluck has decided to buy. So in fact, once we are sure that he will buy that house, we can simply print the information for that house and then return. So we don't even need to read the rest of the file. So this will simplify the code. Otherwise, we have to remember that status, remember the information, and then wait until the end to print it. And also, another a natural first instinct is we look at today's house and then decide whether this house is good enough. And if it is, then we still don't buy it. We sort of somehow remember that this is good enough, and then tomorrow we should decide whether to buy it. So in fact, when I created the problem, when I first write the sample code, that was the first thing I tried. But then I quickly realized, actually, that's not the best way to do it. So in fact, for a number of reasons, that will lead to complicated code. For one thing, we cannot commit to today's house. Because even if it's a good house, we will be waiting until tomorrow to decide whether we're going to buy it, because tomorrow's house may be even better. And also, we actually cannot quite tell whether today's house is good enough. So there are cases where the house is not good enough today. It will appear good enough tomorrow, because tomorrow we may see a house with a higher PPSFM. So because of all these reasons, it's actually better not to do anything for today's house, except we are going to store it, or except actually we need to update the maximum PPSFM. We actually don't need to decide whether today's house is good enough or not. We always look at yesterday's house. Of course, this means at the end of the loop, we need to, after we've looked at all the houses, we need to consider whether the last house is the one that we should buy. So basically, the structure of the code will loop over all houses, and for each house, there are 3 things we need to do. We need to check whether we should buy the house from yesterday. So after looking at today's house, we have all the information we need to decide whether yesterday's house is the one to buy. And if the answer is yes, we will print yesterday's house information and return. And we also need to update the maximum PPSF based on today's house. If today's house has a higher PPSF, then we need to update that. And also then we also need to update the information of the previous house. So remember, these are the 2 pieces of information we said we need to store. Then those information are the ones that we need to update. So one question is, what should be the order between A, B, and C in here, inside the loop for each house? So after the loop, we need to check whether the last house is a good deal, the house available on the last day. If it is, we'll print its info. Otherwise, we will print out of luck, because we look at all the houses, and if we haven't bought a house at this point, Professor is out of luck. So I hope you have a thought about the order of ABC. So the right order would be B, A, and C. So we first need to update the maximum PPSF. And then, because this will be one piece of information used to decide whether the house from yesterday is good enough. And then we do A, and after A, we do C. So only when we didn't buy the house from yesterday, we should update if we do C before A, then we lose the information from previous day. So yeah, should also consider the condition under which condition we buy the house from yesterday, but that's more or less translating the condition given in the problem. So this is part 1 of the code. So these 4 variables store the information for the house available on the previous day, price, room, footage. They also store PPSF, even though it can be computed from that. We also store information of the current house, price, room, footage. These variables need to be outside this repeat loop, outside this statement, because we need to refer to this variable after the loop finishes. At that point, these will store information of the house available on the last day. So price, room, footage, PPSF, and then we also have the maximum PPSF. So inside the loop, we read in the house information, compute the PPSF, and then first thing we do is update max. And then we check whether the house available on previous day, whether it satisfies the condition. So it's spacious, and its price is no more than half the max of a PPSF. So if it is, actually we cannot decide to buy the house from yesterday, because there's one condition that we will still wait, which is the house from today is even better. So we will buy the house from yesterday if either today's house is not spacious, so we're not even going to consider it, or the today's house is have a higher PPSF than yesterday. So yesterday is a better deal. So under this condition, we will buy yesterday's house, approve printing the information, and then return. So otherwise, near the end of the loop, we'll just update the previous house information. So basically, we are done today, and we are going to move today's house information to the variable storing yesterday's information, because next time when we go back to the beginning of the loop, today become yesterday. Today is tomorrow's yesterday. So the code on this slide are the code after the loop. So essentially, we are checking the last house. So at this point, we have not bought any house. So we look at the last house. If the last house is big enough and its price is PPSF is no more than half of a max, then we're going to buy it. If we don't have this code here, then we may be missing the last house. Maybe the last house is the one to buy, but we will not buy it, because inside the loop, we are only going to buy the house from previous day. So because of that, at the outside the loop, we have to check the house from last day to decide whether to buy. So again, the code with the comment is available inside the HackerRank. So you can take a look there. So that wraps up the example problem for topic 1. And there are 5 other problems that are homework problems for this topic. So the first 3 are fairly straightforward. And the last question is a variant of this professor's Goldluck House 4 is a variant of House 2. So if you clearly understand the code for House 2, you just need to make some relatively minor changes for it to work in that problem. And House 3 is standing on itself by itself is actually easier than 2 or 4. Because it doesn't have this feature of even though a house is good enough, you're going to wait till tomorrow. But because it doesn't have that, it's going to be different from House 2. So it's a little bit blend of the Goldluck House 1 and House 2. Okay, so have fun, and I hope you enjoy the videos. And next time, I'll see you for topic 2, in which we'll cover loops and also functions.